So now let's move on to these pillars. What I want to do is have some kind of flagstone design. So something like this would be really cool. So if we go here to the reference and we look through what we have, this Voronoi 3 might work if we can get that to somehow be more evenly distributed. The cell Voronoi might also work, the mod, and the cell noise. So that might work for getting us the general shape. But what I want to do before defining the actual brick shapes is get some kind of base just for the general texture of that stone. So looking again, it's kind of hard to tell with this resolution. But if we go maybe to something that's a bit higher in resolution, maybe something like that, that'll give you a more decent idea. The flagstone isn't actually too rough on the outside. It does have a little bit going on, but it's not like a totally unrefined piece of stone. So if we go back here to our chart, and by the way, I have this displacement chart in addition to the microsurface. So if we go here, maybe something like the Luca looks pretty cool. We can also do the displaced Voronoi, turbulence. If we do the electric, we could turn that down. Same with the gaseous. So I think there's some options there. Let's go for the electric. Let's try that and then just making it a lower intensity. So we'll say RS noise right there. Plug that in. And then let's go to our Redshift render view, press play. Now we have that going on. Let's go ahead and actually not use an RS noise, use a Maxon noise and go like that. There we go. Now if we do the gaseous, we have something like that. Let's go ahead and take the scale down to 0.5. And then also let's try to clip some of our whites so that we have a smooth surface every now and then. So we'll just go ahead and bring that down just a little bit, bring down the contrast, and there's a pretty decent start for what we need to do. Let's also layer on some other noises. I think that always adds a nice amount of complexity. So we can use a color layer to do that. Let's go like this, like that, and then we'll just do a overlay with this guy and just change the offset. So we'll do something right around there. Let's also take the scale and maybe say 0.25. Well, let's actually go up, 0.75. There we go. We'll do that. We'll do it again. Same exact thing. This time we'll do a overlay, which by the way, an overlay, if you're not familiar with what these blend modes are, you really need to look this up. It's just a very quintessential thing in 3D graphics if you're not comfortable with multiply, subtract, what all this stuff is. So if that's you, then I've included a link to this video that you should check out. Just because, again, it's just a very common thing to know. We'll do overlay again, and this time we'll do a electric noise. And let's go ahead and turn up the contrast a little bit on that. Take the scale, do something else with it. There we go. It's just a bunch of randomness, really. I'm just trying to add a bunch of detail so that when we go to the displacements, it looks really cool. RS displacement. Let's go ahead and set this up. A new shader. Plug that into the surface. And then I'm going to pause this video as I hook up the displacement so it doesn't freeze. So we'll say displacement right there. Set the scale to something low to start, 0.001. And I haven't talked about displacement yet, so let's go to our object level. Again, displacement is going to actually move the polygons. It's going to subdivide at render and move those polygons outwards. Now with Redshift, in order to correctly displace something, you need to go to the Redshift OBJ tab, go to Tessellation Displacement. First of all, enable tessellation. That word tessellation means that it's allowed to subdivide itself. And then you also need to go down here and enable displacement so it actually pushes those polygons through the signal. So we have that noise, right? That is now able to push these polygons in those directions. So let's really quickly talk about this. Tessellation is checked. That means we're allowed to subdivide at render. Here I have this maximum subdivisions and it's set to 0. So that basically means that there's no subdivision happening right now. But as I turn this up, notice how it's going to subdivide with each iteration, like this. And the way this generally works is that it's going to keep on subdividing the mesh until it reaches this minimum edge length. And so what this is talking about, and the way this works is that it'll keep on subdividing, and once one of these lines reaches a length of 6 pixels across. So it looks and says, okay, let's say an edge over here is now 6 pixels across, then it stops subdividing that particular area, and it only subdivides in areas that are less or that are more than 6 pixels in length. So in other words, let me try to draw this out. Let me just try to explain this. Let's say let's actually use 4 pixels as an example. Say we're going to render. This is 4 pixels, right? One of these edges, if it's greater in length, if it spans more than 4 pixels, then that means that that particular area is able to subdivide again. And now, if let's say we subdivide that edge and it does something like this, now we are less than that minimum edge length parameter right there. Now these edges don't span more than 6 pixels, and because of that, it can stop subdividing in that particular area. So it's a very cool way of adaptively subdividing the model until we have enough resolution to represent whatever it is. So hopefully that makes a little bit of sense. For more info, you can check that out in the user docs. But that's how that works, and this is what's called screen space adaptive. So it adaptively subdivides based on the number of pixels, this edge length right here, and that's how you get more subdivisions. For this, I like setting this to probably about 4, and then the maximum subdivisions, I think at the default of 6 is pretty good. Don't worry about this out of frustum tessellation. That has to deal with subdividing things that are outside the frame. And also, we don't want to smooth UVs for right now, and that's about it. Also, we have this enable displacement, and the maximum displacement is the maximum amount that it can go outwards, and the displacement scale is just a scaling value on how far the polygons can go out. Last but not least, we also have this enable auto bump mapping. And what that will do is it'll try to make a bump map for the areas of the model that are facing towards us. And so if we go back to our shader here, stone pillars, I'm going to remove this wireframe and instead just bring a normal material in here, so that we have something like this. And don't worry, I worked ahead a little bit, so we'll go back and I'll show you this stuff. But let's say we have something like this, right? If I enable the, on the object level here, the auto bump mapping, that will turn these areas that are facing towards us into a bump map. And it will only displace the areas that are facing along the silhouettes of the object. So this is now technically a bump map that's facing towards us. These areas along the silhouette are actually being displaced. So that's just another way of adaptively subdividing the mesh. We'll talk a bit more about all that in the future, but for right now, let's just leave it at that, and we'll continue on making something that looks kind of like this.